What if everything you know about the beginning of the universe is wrong? Get ready to journey beyond the edge of time itself, a scientific and philosophical exploration of the origin of time and the universe. Introduction. The question, what existed before the Big Bang, is one of the most profound and challenging in modern cosmology. It stands at the intersection of physics and philosophy, touching the very limits of our understanding of time, causality, and existence. To approach it properly, one must first understand what the Big Bang actually represents, and whether the notion of before even makes sense within this framework. 1. The Big Bang, a beginning or a transition. According to the standard cosmological model, about 13.8 billion years ago, the universe expanded from an extremely hot and dense state. This event, known as the Big Bang, was not an explosion in space, but rather the beginning of space and time themselves. In this sense, both space and time came into existence at that moment. There was no before in the classical sense. Satsudan konstatsen bindain zu, or datsen stein, shatendan, the meaninglessness of before in general relativity. Einstein's general theory of relativity, 1915, shows that space and time are two aspects of a single dynamic fabric shaped by matter and energy. If time itself began with the Big Bang, then asking what happened before is like asking, what lies north of the North Pole? The question ceases to have meaning. From this viewpoint, time starts at the Big Bang, and there is no physical before. 3. Scientific theories beyond the Big Bang. Despite this, physicists have developed several models that attempt to describe or reinterpret what might have preceded or replaced the classical singularity of the Big Bang. A. The cyclic model. In the Cyclic Universe model, the cosmos undergoes endless cycles of expansion and contraction. After expanding for billions of years, gravity could cause the universe to collapse into a big crunch, which may then trigger a new Big Bang. The modern version, the ekpyrotic universe, based on string theory, was developed by Paul Steinhardt and Neil Turok. In this theory, our universe emerges from the collision of two enormous branes, multidimensional membranes, within a higher dimensional space. B. The quantum bounce model. In loop quantum gravity, developed by Carlo Rovelli and others, the singularity of the Big Bang disappears. Instead, the universe existed in a contracting phase before rebounding due to quantum effects, a process known as the quantum bounce, or Big Bounce. In this picture, the Big Bang was not the absolute beginning, but a transition from a previous collapsing universe. C. The multiverse theory. In eternal inflation. Theory, proposed by Alan Guth and Andre Linde, inflation never completely ends. Different regions of space stop inflating at different times, creating countless bubble universes. Our universe would be one such bubble. Thus, before the Big Bang could mean a state in which our bubble had not yet formed within the vast multiverse. D. The Hartle-Hawking no-boundary proposal. In the 1980s, Stephen Hawking and James Hartle proposed that, near the origin of the universe, time behaves like a spatial dimension. This removes the boundary of time. The universe has no temporal edge. Like the surface of a sphere, it has no beginning point. The Big Bang, in this view, marks a smooth transition from timelessness to time, rather than a singular moment of creation. E. String theory and brane cosmology. Within string theory, our universe may be a three-dimensional brane floating in a higher dimensional space. According to the ekpyrotic or brane collision model, two branes approaching and colliding released massive energy, manifested as the Big Bang. Here, the pre-Big Bang phase would correspond to the slow motion of these branes before collision. 4. Summary table. Theory. Before exists. Core idea. Standard. Big Bang. No. Time begins at the Big Bang. Cyclic. Ekpyrotic. Yes. Infinite cycles of expansion and contraction. Quantum bounce. Yes. Bounce from a previous universe. Multiverse. Yes. Our universe is one bubble in a vast multiverse. Hartley-Hawking. No, but smooth. No boundary. Time becomes space. String. Brane. Yes. Brane collision in higher dimensions. Conclusion. The question of what came before the Big Bang marks the frontier between physics and philosophy. While the standard model defines the Big Bang as the beginning of time, quantum and string-based theories suggest it may have been a transition, not an origin. Perhaps the Big Bang is not the first chapter of existence, but one in an infinite cosmic story still unfolding. Settings: use only generated clips, use hyper-realistic style, use factradamos as watermark text,